Hey everyone, and welcome back. Ready for another deep dive?
Always.
Awesome. Today we're tackling a topic that's, well, pretty electrifying. Avionics.
Sounds exciting.
It is. We're going to be digging into the NCTT AET test study guides, the 2020 editions, volumes 1 and 2. They're kind of like the Bibles for anyone wanting to become an aircraft electronics technician.
Oh, yeah. Those are essential.
Totally.
Yeah.
But here's the thing. We're not just going to, read out the questions and answers. We're going deeper. Think of it like we're exploring the why behind the what of aircraft electronics.
I like it. Getting into the nitty-gritty.
Exactly. And we'll even touch on some aviation history along the way. What do you say? Ready to get started?
Let's do it.
Perfect. So, the NCATT AET certification, it has a history of its own.
It does. It wasn't always the go-to, though.
Right. The guide even mentions that it replaced the older FCC GROL test, right?
Yeah, the FCC test was useful, but electronics on aircraft, they've changed so much that older test wasn't really keeping up.
It's like showing up to, I don't know, fix a jet engine with tools from your grandfather's shed.
Exactly. Not ideal. The NCTT AET, though, it gets that the industry needs specific skills, especially for working on the kind of electronics you see on modern aircraft. That's why employers like it when you have that certification.
It's proof,
Yeah.
Like, here are my credentials. I can handle this stuff.
It's a big deal in aviation. Safety is everything, so knowing someone has the right skills, that's golden. It's not just about, say, knowing how to change a light bulb. It's about understanding all the systems that make that light bulb work perfectly, even after flying thousands of miles.
Right. So much complexity behind the scenes. Okay, so let's jump into volume 1. First up, resistors. Now, they seem pretty basic, but the guide really emphasizes how important it is to identify them.
They are important. And there are different types, too. Like the guide mentions axial resistors, those are the ones with the little legs, and surface mount resistors, those are usually found in newer equipment.
It's like the difference between, say, an old desktop computer and a new smartphone.
Yeah.
Right? They both work, but one's definitely more modern.
Exactly. And you've got to know the difference.
For sure. And remember those colored bands on axial resistors? That's where it gets interesting. The guide gives this example: orange, yellow, silver. It's like a secret code.
Well, it is a code, and every aspiring avionics technician needs to know how to crack it. Each color band, it stands for a specific number or a multiplier. So orange, yellow, that would be 334. And the yellow, that means you multiply by 10,000. So this resistor, it has a value of 334,000 ohms, or you could say 334 kilo.
Okay, got it. So what about the silver band? That's the last one.
Ah, that silver band. That's the tolerance. It tells you how much the actual resistance of the resistor can vary. With silver, it means plus or minus 10%.
Tolerance, huh? Why is that so important? It seems like a small thing.
In avionics, even small things can be a big deal. Imagine a resistor that's part of the fuel gauge system. If the resistance is off, even a little, because of bad tolerance, that gauge might show more fuel than is really there.
Oh, wow, that could be a disaster.
Exactly. It's not an exaggeration to say that understanding tolerance in avionics is about keeping people safe.
That makes a lot of sense. It's more than just passing a test.
Way more.
Okay, so the study guide connects these resistors to DC and AC circuits. And that leads to another pretty important concept: RMS.
Ah, RMS. This is where things get interesting.
Right. And the study guide has this great analogy. They compare DC to a bandsaw and AC to a jigsaw.
Oh, I like that. Visualizing it really helps.
I know, right? So think about it. A bandsaw, just like DC, makes a really smooth, constant cut. But a jigsaw, like AC current, it moves back and forth. So RMS, which stands for root mean square, that helps us measure that back and forth cutting action of the AC.
It's basically a way to figure out the DC equivalent of an AC voltage or current. Like if we were using DC instead of AC in the circuit and we wanted the same power, what would the voltage or current need to be? RMS gives you that answer.
That's really helpful. So if you're an avionics technician, why do you even care about RMS?
Good question. Let's say you're testing the lighting system on an aircraft. You've got to make sure those bulbs are getting the right amount of power, not too much, not too little. Too much and they burn out super fast. Too little and, well, they're too dim. RMS lets you measure that AC voltage or current precisely, even though the current's constantly changing direction.
So it's like making sure the jigsaw is set to the right speed for the material you're cutting.
Exactly.
Okay, so from currents, let's talk about something that seems kind of simple at first.
Yeah.
Transformers. They look like just coils of wire, right?
They do, but those transformers, they're important. They change the voltage levels in a circuit, and that's a big deal in aircraft.
Right, because you need different voltages for different systems.
Exactly. And the way transformers work is really interesting. They use something called electromagnetic induction. Basically, they can transfer electrical energy from one circuit to another without the circuits actually touching. Pretty cool, right?
It's like magic, but with, science.
Exactly. And speaking of science, there was something in the guide that caught my eye. It said that the core of a transformer is often made of laminated iron. Thin sheets stacked together instead of a solid chunk of iron. Why do they do that?
Hmm, that is interesting. Is it just like a manufacturing thing?
Good guess. But it's actually a lot more clever than that, those laminations. They reduce something called eddy currents. Imagine these little whirlpools of energy forming in the iron core. They waste power and they generate heat, which you don't want.
Oh, I see. So it's like friction, but for electricity.
Yeah,
So,
you got it. And those thin layers, they stop those eddy currents from getting too big, making the transformer way more efficient.
that's so cool. It's amazing how much thought goes into these things that most people never even see.
That's avionics for you. Every detail matters.
True. And speaking of things that matter, safety is a big one. Yeah.
Huge. I mean, you're dealing with complex systems, high voltages. Safety has got to be the #1 priority. And the study guide really emphasizes that. It even lists the 3 main causes of electrical accidents:
Hmm.
unsafe equipment, unsafe work environments, and unsafe work practices.
It's like a good reminder, because even the most advanced technology in the world isn't going to be safe if the people using it aren't being safe.
100%. And the guide even points out a specific safety regulation, and this one's important. When you're working near power lines, every single part has to be grounded or insulated, no exceptions. And honestly, even if you think something isn't live, you treat it like it is.
It's like that saying, right? Better safe than,
Sorry.
oh, better safe than sorry. But in avionics, that's not just a saying. It's like the rule.
You've got that right. And part of being safe is using the right pursuit Range Rover. Personal protective equipment, PPE for short. Do you know how important that is in avionics?
Oh, yeah, the guide mentions it, like wearing gloves and shoes that don't conduct electricity so you don't become a circuit yourself.
You got it. And insulated tools. And don't forget the head protection. It's about layers of protection. You're minimizing that risk however you can.
It's like, suiting up for a dangerous mission. You wouldn't go into a hazardous environment without the right gear. And working on aircraft electronics is no different, especially with those high voltages. PPE is your best friend.
It's not just about protecting yourself either. It's about protecting that aircraft. One little static shock from your fingertip can fry a sensitive electronic component, and then you're in a whole world of trouble.
Oh, man. And that actually reminds me that the guy talks about ESD, electrostatic discharge. That's the fancy name for static electricity.
Right. And you might not even feel that static discharge, but it can still cause some serious damage.
It's crazy to think that something we can't even see, like static, can generate thousands of volts. Thousands.
I know. The guide even says that just walking across a carpet can generate 1,500 to 35,000 volts.
Wow. That's a lot. So how do you stop it?
Well, you've got to take precautions, right? The guide talks about things like wearing a wrist strap that grounds you to the work surface, and using a grounded work surface, of course, and handling all those sensitive components really carefully, making sure they stay in their anti-static bags until you need them.
So it's like you're creating this, safe zone for the electronics where static can't get them.
Precisely. You've got to be meticulous in avionics, that's for sure.
Makes sense. It's not just about knowing how to solder. It's about understanding these invisible forces, too, that could cause problems.
Exactly.
So the guide goes on to talk about aircraft blueprints, technical drawings. It's like a whole other language you have to learn.
Oh, for sure. It's essential. Those drawings, they're the roadmap for every avionics technician. They show you how everything is supposed to go together, where the wires run, all of it.
And there are different types of drawings, right? Like the guide mentions, let me see, detailed drawings, assembly drawings. There are installation drawings and sectionals, even exploded views. What are those?
So each drawing type serves a purpose. Detailed drawings. Think of them like close-ups, They show the nitty-gritty of each individual part. Assembly drawings, well, they show how those parts fit together to make, you guessed it, assemblies. And the installation drawings, those show how those assemblies go into the actual aircraft.
Okay, and the sectionals.
Sectionals. Imagine you slice through something, like a cake, to see the layers inside. That's what a sectional drawing is like. It shows you the insides of things, the components, the systems. It's all about getting a clear picture of what's going on under the hood, so to speak.
Got it. And exploded views. Are those as dramatic as they sound?
Haha, not really. Imagine you took something complicated, like a clock, and you laid out all the pieces neatly, showing how they fit together. That's kind of what an exploded view is. It's super helpful for putting things together or taking them apart.
So it's like having the ultimate instruction manual, showing every little bit and piece.
Exactly. And being able to understand these drawings, absolutely crucial for any avionics technician.
Makes sense. So what about wiring diagrams? Those seem pretty important too.
Absolutely. Wiring diagrams are like the electrical roadmap of the aircraft. They show you the path of every single wire, how they're connected, how the electricity flows through the whole system.
It's like following the veins and arteries of the aircraft, except instead of blood, it's electricity flowing through, keeping everything running.
Great analogy.
Yeah.
And those diagrams, they're your lifeline when you're troubleshooting electrical problems. They help you figure out what's not working right, where the bad connection might be, things like that.
It's all connected, literally. So these wiring diagrams, they can be really complex for bigger aircraft, right?
Oh, definitely. You can have hundreds, even thousands of wires in a large aircraft. It's mind-boggling. That's why it's so important for those diagrams to be standardized. So anyone who is qualified anywhere in the world can look at that diagram and understand it.
It's like a universal language for aircraft wiring.
Exactly. And that's one of the things organizations like NCT do. They set those standards, making sure that everyone's speaking the same language when it comes to avionics.
So we've talked about all these complex systems, all that wiring. It makes you realize how important troubleshooting is going to be for an avionics technician.
Oh, absolutely. It's where the rubber meets the road, taking all that knowledge and putting it into practice.
Right. And the study guide, it really emphasizes that you've got to have a system.
A system.
Yeah, like a process.
Yeah.
You can't just start, ripping out wires and hope for the best.
Uh-huh. No, that's not going to end well. It's like trying to fix your car by randomly hitting the engine with a wrench.
Exactly. So the guide, it compares good troubleshooting to the scientific method.
No, that makes sense.
Right. It's about observing what's going on, getting all the information you can about the system, coming up with an idea about what's causing the problem, and then testing that idea step by step.
It's like you're a detective, except instead of looking for clues at a crime scene, you're looking for clues in the wiring.
I love that analogy.
Yeah.
And to help illustrate this, the study guide throws in a little scenario. Let's say you've got a radio altimeter that's giving you all sorts of crazy readings.
Ooh, that's a good one. Radio altimeters are critical. They tell you exactly how high the aircraft is above the ground. If those readings are off, big problem.
Definitely. So what's the first thing you check?
Well, the guide says you always start with the most basic thing. So in this case, the antenna and the cabling. The sensor itself and how it's connected to the rest of the system.
So if the antenna's busted or there's a loose connection, you're not going to get good data.
It'd be like trying to listen to the radio with a coat hanger for an antenna. All static, no music.
Exactly. Okay, so let's say the antenna and the cabling, they all look good. What's next?
Well, then you move deeper into the system, the receiver itself. That's where things get a little more technical. You'd use special equipment to see if it's as sensitive as it should be, if the frequency is accurate, things like that.
So you're making sure the receiver is doing its job, picking up those signals from the antenna.
Precisely. But let's say even the receiver checks out A.
Okay. Getting trickier. What then?
Well, then you start thinking about things outside the system itself. Maybe there's interference, like some other piece of equipment on the aircraft is using similar frequencies and messing up the radio altimeter's readings.
So it's like trying to have a conversation at a rock concert. All that noise makes it hard to hear.
Exactly. And sometimes, just like you might move to a quieter room to hear better, technicians might try to isolate the radio altimeter, see if they can get rid of that interference. It's all about finding the source of the problem.
It's amazing, though, how much problem solving is involved in being a good technician. It's like you need to know the theory, but you also need to be able to think on your feet.
100% agree.
Okay, so another thing the guide mentions is documentation.
Oh, documentation. Don't even get me started. It's so important, though, right?
Right. But why is it so important?
Well, for one thing, it helps the other technicians. If you've done some troubleshooting, you write down what you found, what you fixed. That way, if someone else has to work on that same system later, they don't have to start from scratch.
It's like leaving a trail of breadcrumbs, but for avionics.
Haha, exactly. And it's also really important for tracking problems that come and go, and of course for safety. You need to be able to prove that you did the repairs correctly, that everything is up to code. Documentation is how you do that.
Right. It's all about safety and accountability in the end. Okay, speaking of which, the guide gets into some pretty serious territory. FAA regulations, FARs, all of that.
The FAA, man. They're like the referees of the sky. They set the rules. Everyone's got to follow them, no exceptions. And those rules, those are the FARs. The federal aviation regulations, everything's in there. From how you design and fix aircraft to who gets to be a pilot and how they fly. It's serious stuff.
Intense. The guide specifically mentions the 100-hour inspection. What is that?
Okay, so the 100-hour inspection, it's like a checkup for an airplane, but mandatory. If that aircraft is being used for hire or for flight instruction, every 100 hours of flight time, boom, it's got to get inspected.
Makes sense. So do technicians do these inspections?
They're a big part of it. They make sure that everything is in tip-top shape, meeting all those strict FAA standards, the ones we were just talking about. That includes all the avionics, of course.
So it's like taking your car to the mechanic for a tune-up.
Exactly. It's preventative maintenance. You catch those little problems before they turn into big, dangerous ones.
It all comes back to safety, doesn't it?
Always does in aviation.
That's so true. And it makes you realize that these NCATT AET test study guides, they're not just about memorizing a bunch of facts. They're about understanding something way bigger. They're about this whole world of avionics where everything's connected.
They are. It's amazing when you think about it. All those circuits and wires and components all working together to get those massive machines off the ground and keep them flying safely.
It's mind-blowing. We've talked about so much in this deep dive. Those tiny little resistors with their color codes, the power of transformers, how to read all those crazy complicated drawings, and how to troubleshoot when something goes wrong. It's a lot to take in.
It is, but it's so cool. Avionics is a fascinating field.
It really is. And whether you're just starting out on your journey to becoming an avionics technician or you're already deep in the game, remember this. It's more than just wires and boxes. It's about human ingenuity, about pushing the boundaries of what's possible.
I love that. And never forget the importance of safety.
100%. Well, on that note, I think we've covered a lot of ground today. A huge thanks to you for joining us on this electrifying deep dive into the world of avionics. And until next time, happy flying.